Did you ask yourself which path of the software developer to choose? Become front-end engineer, craft backend applications, or master both parts and become highly paid full-stack web developer? In this video I would like to focus on the differences between front-end and backend, and I'll explain to you their building blocks. Also, you'll understand how any web application works. Hi, my name is bstashchuk and I am teaching hundreds of thousands of students all over the world. And I worked really hard to craft this video for you. No code and long exercises this time, just take a cup of tea or coffee, relax and bear with me for the next half an hour. Enjoy! Let's have a look at the web development from the bird's eye view. And let's start with discussion of the differences between front-end and backend. This is iceberg. And as you probably know, on average only 1/10 or 10% of an iceberg is above the surface of the water. The rest is under the surface and therefore not visible for people sailing on a ship next to an iceberg. In the web development world, part of the iceberg above the surface is front-end or client side. That's everything a user sees or directly interacts with, for example, buttons, menu, text or images. Some end users think that what they actually see in the web application is application itself, and there is nothing behind it. But almost for each front end, there is hidden from the end user backend or server side. And backend part, like as in the example with iceberg, is usually way more larger than visible front end part. And in many cases it is so huge that end users can't even imagine. Backend is responsible for actual application logic. It also contains data and provides access to the data for the front-end applications. Backend could consist of hundreds of different pieces called microservices. Considering all of the above, we could conclude that front-end and backend are closely related and both form actual web applications, which you and I use on our laptops and mobile phones. That leads us to the term full stack. Full stack term is usually applied to the development process itself. Also, it is applied when talking about roles of the software developers in the development process. There are front-end developers, back-end developers, and full stack developers. Full stack developers are usually being paid the most. That's because in order to be full stack developer, you have to master skills required for creation of both parts of each web application, namely front-end part and back-end part. On the other hand, great front-end developers usually possess good knowledge about backend, and vice versa. Backend developers should know key building blocks of the front-end application they craft backend part for. If you want to become a full-stack web developer, I welcome you to my full-stack web development bootcamp, where you'll gain hands-on experience by building a real-world application. And you'll utilize same tools and technologies that software engineers use day by day at work. And you'll build such full-stack application using two most commonly utilized programming languages in the world: JavaScript and Python. You'll build front-end application using React library, that is JavaScript library, and on the backend side you'll build API service by using Python. Other than that, you'll also utilize such tools and applications like Git, GitHub, VS Code, Docker, Postman, and many more. Link to the course you'll find in the description under this video. Web applications could have millions of end users who launch web applications on different devices like mobile phones, desktop computers, tablets or laptops. And there is no need to create a separate backend for each front-end device. It would be just simply waste of resources. Therefore, all client devices usually communicate with the same backend. But this backend could be spread across the globe, and different servers could serve different clients depending on their location in the world. But backend applications which are running on those copies of the backend servers are usually the same. This means that there is no need to create separate backend applications for mobile phones and desktop computers. Now let's discuss the building blocks for the frontend and backend, and let's start with the frontend, because it consists only of 3 different blocks. And those blocks are HTML, that stands for Hypertext Markup Language, CSS, that stands for Cascading Style Sheets, and JavaScript, the most popular programming language in the world. HTML defines structure of the web application, and using HTML you could tell web browser that in specific place of the web page should be an image. Underneath it should be the text which describes this image, then input form to enter a comment about that image, and finally button to submit that comment. Web pages without styles would look really boring. Using CSS you could define different styles for elements on the web page. For example, define width and height of the image, define color and font size of the text, or add shadow to the button. You could create nice-looking web application using only HTML and CSS, but such web application will be static. If you want to make such application dynamic and respond to user actions, for instance clicks on the buttons or inputs in the text forms, you have to utilize JavaScript programming language. It's like an engine in your car, which allows you to drive it into different directions. JavaScript handles user actions, and also it is responsible for communication with the backend. HTML or CSS could not do such job. In comparison to the front end, backend is much more complicated. Many different technologies are usually utilized in the backend part. Some of the backend parts could be written using Node.js, some of them using, for instance, Python or Java. For example, one server could host static CSS, HTML and JavaScript files for the front-end clients. Node.js microservice could communicate with the MongoDB database. Java application could interact with Redis, and so on. And all of those parts of the backend could be running using Docker and Kubernetes in the cloud provided by Amazon, which offers Amazon Web Services. Those backend parts could be combined into 3 different groups. First group is a group of programming languages such as Node.js, Java, Python or C#. Programming languages are used in order to build APIs, application programming interfaces, and actual backend logic. Using programming languages you could implement, for example, communication channel with databases and perform different write or read operations on behalf of the front-end clients. Databases belong to another group of backend technologies, and there are 2 main types of databases: SQL or relational databases, and NoSQL databases. MongoDB and Redis are considered NoSQL databases and don't have strict requirements to the format of data stored inside of them. MongoDB is the most popular NoSQL document database where different documents with various sets of fields are stored in different collections. Redis is a very fast key-value database which stores data in RAM, and therefore very often utilized for caching, queuing and real-time data processing. On the other hand, SQL databases such as MySQL, PostgreSQL lay down certain strict requirements to the format of each record stored inside of them, and both of them are usually used for long-term storage of the structured data. Data is stored in different tables with established relations between them. Remaining technologies used in the backend I placed into one group and I called it infrastructure services, though they could be split into different subgroups. Docker and Kubernetes help to build and run actual backend applications written using different programming languages and also databases. ELK, which stands for Elasticsearch, Logstash and Kibana, help to implement monitoring, logging and search functionality for the backend services. Apache Kafka is high-speed messages exchange between different services, which is programming language agnostic. Therefore, different services could talk to each other via Apache Kafka. AWS or Amazon Web Services are cloud-based services which are very popular in the large enterprise world. In the AWS cloud, you could run literally any service, either backend or frontend. Frontend? Surprised? But it is only client-side. Front-end applications also have to be hosted somewhere in order to provide for the clients access to the HTML, CSS, and JavaScript files. And that's what AWS or Google Cloud or other hosting services are utilized for as well. Let's now return to the front-end part and discuss anatomy of each front-end application. Front-end applications are created for the end-user devices with screens, but actual content which is displayed on those screens should be somehow transferred to those devices. And as we discussed before, clients need to get HTML, CSS, and JavaScript files to be able to properly display and run specific web application. Those files have to be hosted on the server, which is also part of the front-end application. That's actually the place where built front-end application files are hosted, or where, for instance, dynamic CMS content management system is running. Thus, server has either static HTML, CSS, and JavaScript files, or dynamic, which are created upon each specific request from the clients. And those HTML, CSS, and JavaScript files are distributed to the clients over the internet in order to make them able to run specific front-end application. That's how each front-end application essentially works. Also, during life cycle of the front-end applications on the client devices, they might send additional requests to the servers asking for some additional data, like images or text information retrieved from the databases. Or they might submit some data from the users to the servers. And now let's discuss how clients and servers actually communicate with each other. They communicate in the form of requests and responses, and for a single web page, client application could send multiple requests to the same or different backend servers. Let's examine lifespan of the single request to the server. User opens web application. It initiates a request to the server. And depending on the request, server could either immediately send response, if it is, for example, request for CSS style sheet that is hosted directly on the same server, or send another request or even multiple requests to other servers. For example, if user in the web application tries to log in into its user account, backend server needs to verify username and password supplied by the user and read user profile data from the database. After authentication and retrieval of the user data from the database, it prepares a response for the client and sends it back. Now this request-response exchange is considered as completed. But now the same user could grab the phone and launch one of the mobile apps, and the mobile app will also initiate a request to the same or other server, for example, checking whether there are new email messages or retrieving update for the weather forecast app. Server again does its job and prepares a response for the client by making other consecutive requests to other servers, and when data is ready, sends a response back to the client. Technically, for the server, it doesn't matter which type of application is running on the client side, or which phone model client holds in his hands. What does matter for the server is format and structure of the request that is received from the client. But how technically client and server actually communicate? As you noticed in this simplified example, same server hosts static files such as HTML, CSS, and JavaScript, and also processes data requests from the clients and interacts with database. But very often in the real-world projects, such roles are assigned to the different servers. Some host static assets and process requests for them. Others provide access to the data in databases via application programming interfaces. Most common protocol for communication between clients and servers is HTTPS. that is secure version of the HTTP protocol. HTTP is abbreviation of the Hypertext Transfer Protocol. HTTPS relies on the digital certificates and TLS protocol. Data which is transmitted over HTTPS is encrypted, while data that is sent over HTTP is in clear text form. HTTPS protocol itself supports retrieval of static resources like images or text files, which are essentially CSS, HTML, or JavaScript files. But let's now assume that client wants to interact with server and, for example, obtain some text data or modify some information in the database. For example, it needs to request user profile in order to display it in the user interface in the web application, and send further requests for the data which is related to that specific user. For example, list of favorite user songs or list of user posts. Or user has deleted specific post in the user interface, and now client needs to request server to delete the same post from the database as well. This where some sort of languages spoken and understandable both by clients and servers have to be used. And first of the most commonly utilized such kind of languages is REST API. REST API is an application programming interface that conforms to the requirements of the REST architectural style and allows for interaction with RESTful web services. In the REST API, server exposes multiple endpoints with different methods enabled for them, such as get, post, or delete. And clients send requests to those different endpoints, depending on the data they want to retrieve or modify or delete at the server side. Another popular language is GraphQL, which obviously stands for Graph Query Language. In GraphQL, there is just single endpoint on the server side, and clients make consolidated requests for data using such single endpoint. Both REST API and GraphQL rely on HTTPS protocol for actual secure transmission of the sensitive information between clients and servers. Now let's focus a bit more on the front end and discuss what is responsive layout. Responsive layout is layout of the front-end application that smoothly adjusts depending on the screen size. Why is that important to consider while developing front-end applications? Obviously, because now more than 50% of the global website traffic is generated by mobile phones. Layout of each front-end application should automatically adjust to different screen sizes depending on the device being used by the end user, either desktop or tablet or mobile. Layout should be also adjusted depending on the device orientation, which is obviously applied only to tablets and mobile phones. And it's a common convention to say that when user rotates mobile or tablet into the landscape mode, it is expected to see more data than it is visible while using device in the portrait orientation. Therefore, developers of the front-end applications should take that into account and enrich view, show for instance additional blocks of text or additional columns in the tables when user rotates its device. But how responsive layout could be implemented in the front-end applications? Which tools are used for that purpose? Let's have a look at some of them. Mobile-first design. This is an approach in design and development of any modern front-end application which requires to start actual design with the mobile user in mind and adapt application to the mobile devices first and only then expand it to the desktops. Opposite approach is wrong because it is much more difficult to adapt desktop application to the mobile than initially design application for the mobile users. CSS media queries. They are used to target end-user device or web browser by certain characteristics, features and user preferences, and afterwards apply specific styles depending on the target properties. For example, text color could be dark and background light when user opens application in the daytime, and reverse colors to make background dark when user opened application in the evening or at night to make application usage more comfortable for the user. This is achieved using CSS media queries. Elements in the front-end application could be sized in their relative units. For example, size of the images and buttons could be defined in percents of the device viewport. Font size could be defined in the REMs, which are calculated based on the size of the root element, which is HTML element for web applications. CSS Flexbox or Flexible Box model is a layout model which greatly simplifies positioning of the elements on the screen, depending on the screen size. You could control dimensions of each item, quantity of the items in each row, relative positioning of the elements, and spacing between them. There is also another approach to achievement of the nice look and feel of the front-end app on different devices. It is separation of the CSS files for mobile and desktop. It is very easy to detect the type of the device which makes actual request to the server, as this information is usually located in the user agent field of the HTTP request. And after such detection, server could send different CSS files in the response depending on the type of the end-user device. And one more technique is usage of the subdomains for mobile applications. After detection of the user device, mobile users are redirected to the subdomain of the primary domain. And primary domain serves requests made from the desktop computers. Such approach simplifies development, and technically you could even create two completely separated front-end applications, one for mobile and one for desktop users. But there are also drawbacks of usage of such technique, and that's sharing of the URLs between different users that could lead to the cases when mobile-only link is opened on the desktop computer and user sees strange stretched mobile-only version of the application. But that could happen in case of improper redirection of such request back to the primary domain. To summarize, there are multiple techniques which help to create responsive, cross-platform and cross-device layouts which look nice and friendly on all kinds of the end-user devices. Let's now discuss how traditional web applications work on the client side and how navigation between different URLs happens. In the traditional web application, when user opens, let's say, URL https mywebsite.com, which is basically root URL for the domain mywebsite.com, your device downloads HTML, CSS, and JavaScript files specifically and only for this single URL. But as soon as you click on other hyperlink on the web page, for example, contact page, your web browser again makes all requests for the HTML, CSS, and JavaScript files for that web page, and of course, between root page and contact page, web browser will completely re-render page, and you could even see empty white screen for the short period of time. This means that actual web pages are actually rendered on the server side, which is called server-side rendering, shortly SSR, and afterwards are sent to the client. Of course, some resources such as CSS could be cached by web browsers if they are the same for all pages, and there will be no need to download them again and again for each page of the web application. Same happens when you navigate to other pages like About or Profile. For each of those pages, web browser downloads from the server rendered page, which consists of HTML, CSS, and JavaScript. There are a bunch of content management systems, shortly CMS, which offer traditional approach to the web pages navigation and rendering of those web pages on the server side. And most popular of them is WordPress. Let's now examine how single-page applications, or shortly SPAs, behave in comparison to the traditional web applications. Behavior of the SPA is very similar to the traditional web app in terms of the initial request. When you access SPA front-end application for the first time, your web browser or mobile application initially sends requests for HTML, CSS, and JavaScript files to the backend server. CSS and JavaScript files received in response contain all logic for entire web application, for all its pages. Though there are techniques which allow to split actual application logic and styles into the different sub-files, which are downloaded from the server on demand. But key point is that HTML page is downloaded only once. After such initial requests, client has all necessary resources to render other pages like About, Contact or Profile. And such render client does on its own without server help. How it does that? By modifying contents of the DOM, Document Object Model, in the web browser. And those modifications are done seamlessly without page reload. And they are done, of course, by JavaScript. Now client is responsible for the client-side pages rendering instead of the server-side rendering. But client still could send a request to the server for optional data required for some pages. For example, user profile could be retrieved from the server by making REST API or GraphQL request over HTTPS protocol when client navigates to the profile page in the single-page application. That's basically how tiny actual HTML file could be in the SPA applications. As you see, it consists only of HTML head and body with single div inside of it. That's that simple. All further modifications of the HTML file which user sees in the web browser while using front-end application are performed by JavaScript. But it is not an easy task to do all such kind of modifications on the client devices. And that's where different frameworks for building SPAs come in. There are several nice frameworks for building different kinds of the web applications, starting from the small till huge enterprise applications with hundreds of pages and very complicated logic. Here are some examples of such frameworks and libraries: React, Angular, Vue, Svelte, Ember and Meteor. Most popular are React, Angular and Vue. React and Vue are very flexible and they are used by companies and businesses of different sizes. Angular is a solution more for large enterprises. Also, React and Vue have shorter learning curve in comparison to Angular. Certainly, there are pros and cons in usage of the single-page applications in comparison to traditional web applications. Let's start with pros. Web pages are not reloaded during user activity. For example, when there is e-commerce website and when user adds a specific product to the cart, then cart is updated automatically without page refresh and you'll see quantity of the items inside of the cart in your user interface. Better user experience because app feels responsive and fast. Because there is no reload of the pages, of course, user feels that app is much more responsive and it works faster than traditional web application. Easier to deploy because SPA contains only few static files, and they are HTML, CSS and JavaScript. All what you need is to host such files somewhere on the server and allow clients to download such resources. That's it. Effective bandwidth usage. As we just discussed, client downloads HTML, CSS and JavaScript files only once during initial access to the web page. That's why bandwidth is not wasted and we don't send same files over and over again. But there are also cons in usage of the single-page applications. First one is that additional server configuration has to be done for crawling by bots, such as Googlebot, for proper SEO, search engine optimization. For example, you have to take into account that when user tries to access any web page on the website and it is initial request, then you should send to this user same HTML file as you send for other pages and same CSS and JavaScript files. It is of course configurable on web server side. There is also another drawback in usage of the single-page applications. When you create a bundle of files CSS, HTML and JavaScript for production usage for serving to the clients, size of such bundle could be really large, because it contains all application logic, and that could of course impact initial page load time. But there is a technique that allows to combine client-side rendering and server-side rendering to increase initial page loading time. Now let's put everything what we discussed together and let's have a look at the sample web application architecture. Although I made it really simplified, and in the real-world projects architectures are much more complicated and they might contain hundreds of different microservices and connections between them. However, this example could give you a high-level understanding how backend is usually structured. As usually, there are many different users with different types of devices. And there is backend with multiple servers which perform different tasks and have different responsibilities. Clients interact with front-end server and download HTML, CSS and JavaScript files. In this example, front-end server doesn't have connection to the database and it hosts only static files. And I have assumed that one of the frameworks for building SPAs was used here, for example, React or Vue. Clients initiate also different requests for additional data required for the user interface. Also, they send requests for data modification or removal, and those requests are sent to the API server. This API server interacts with MongoDB, for example, and performs all sorts of CRUD operations using MongoDB client. CRUD stands for create, read, update, and delete. These are 4 common operations performed inside of the databases. Also, there is processing server that performs some sort of routine tasks with the documents in the MongoDB database. For instance, it calculates quantities of the posts for each user and writes those quantities into the user profiles in the same database. In order to perform many different processing operations, it uses some sort of queuing mechanism to perform jobs one by one, and information about jobs is stored in the caching Redis database. All mentioned servers send logs related to their operations to the ELK server, which consolidates and saves those logs for future analysis. For example, API server sends logs about each client request, and later on you could find which client made specific API request at a specific date. Also, different logs related to the servers themselves are also sent to the ELK. For example, Redis server could send a warning log when it starts running out of memory because configured memory threshold was exceeded. That's sample, though very simplified architecture of the web application. Let's summarize. Front-end and backend are 2 parts of any web or mobile application. Clients and servers interact with each other via World Wide Web. Backend is usually much larger than front-end users could imagine. Full-stack developers are valued the most. Therefore, I recommend to you to learn how to build both front-end and backend applications. Thank you so much for watching. If you watched this video till this moment, I'm very proud of you, and I hope you get some useful information and now you clearly understand differences between front-end and backend, and you could wisely choose further path for you as a software engineer. If you enjoyed this video, please leave a like, share it, and ask any questions if you have them in the comment section under this video. And also, I hope to see you in my full-stack web development bootcamp. And see you in the next videos. Bye-bye.